Hello, my name is Michael Souza, and this is my rendition of the 2023 Atlantic hurricane season outlook. Now, before I dive into what we could possibly expect for the Atlantic hurricane season this year, I really just want to take a second just to talk about the differences between La Nina and El Nino, simply because they strongly influence how much tropical activity we tend to see on a year-to-year basis. Now, over the last 3 years, we've really been in a more moderately strong La Nina, which La Nina is really just when the trade winds, which the trade winds are just the jet stream winds in the tropics that blow from east to west, they end up being stronger than normal. And what that does is it takes all that warm equatorial water in the Pacific and it pushes it closer to the Asia and Australia continents. In return, the colder water that's deeper in the Pacific, that's off the coast of South and Central America, now replaces that warm surface water, and you have pressure differences that develop as a result. So this disrupts the jet stream in a way that makes tropical cyclone formation in the Atlantic basin more favorable. Now, El Nino is really just the opposite. El Nino is when the trade winds, they still blow from east to west, no matter what time of year it is, but the trade winds end up being weaker in nature. So it allows that warm equatorial water to simply snap back closer to South and Central America. And this disturbs the jet stream in a way that makes conditions less favorable for tropical cyclone development in the Atlantic basin. Now, this is what's currently ongoing. Here in this image, you could see an example of what a moderately strong La Nina looks like. This is from December of 2020. Here in the circled yellow with the two red arrows, you can really see how strong the trade winds are. You can see that it's really blowing all of that air and associated with blowing all of that warm equatorial water closer to the Asia and Australia and even into the Philippines, where you have weaker trade winds off the coast of South and Central America. However, as of May of this year, you can see how those trade winds have really weakened in nature. And so now you see weaker trade winds getting to the Asia and the Philippines and down through Australia, where you can see a little bit more of an uptick in winds closer to the Americas. When you look at sea surface temperature anomalies, what you really notice here is you really see this cold tongue of colder equatorial water that stems from the coast of Peru and goes into the central portion of the Pacific Ocean. Now, closer to the Asian continent, you can see where all the reds and oranges and even the dark reds or almost black-like colors, you can see that's all the warm equatorial water. This is indicative of a La Nina year. Whereas right now, you can see how that cold tongue has really started to fragment in nature, and you can see how we're starting to see pockets of warmer water starting to sprout up closer to the Americas. So in terms of what we can expect for this 2023 Atlantic hurricane season, this is just my own thoughts. There are other entities out there like Colorado State University and the Weather Channel and other entities who have different opinions on what we can expect for this hurricane season. And what's important to note is that NOAA will release their hurricane outlook on May 24th. However, when you look at the 30-year average, typically for any given hurricane season in the Atlantic, we usually average about 14 tropical storms, 7 of which become hurricanes, and 3 of which become major hurricanes, which a major hurricane is categorized by a category 3 or higher. But I think for this year, given that we're going into a more El Nino-like pattern, I'm thinking a little bit less in terms of tropical activity, with 8 to 10 tropical storms, 2 to 4 of those being hurricanes, and about 1 to 2 of those being major hurricanes. Now, the reason for this is that, remember, with El Nino, it disrupts the jet stream in a way where we tend to have more high pressure zones out in the Caribbean, sometimes even in the Gulf of Mexico, and even into the central portion of the Atlantic. With those high pressure zones in place, what it really does is, since high pressure spins in a clockwise fashion and low pressure spins in a counterclockwise fashion, any weak cluster of thunderstorms that's spinning counterclockwise or even beginning to spin counterclockwise really isn't in a favorable environment due to the strong nature of how high pressure systems move and rotate. And that's what's known as that strong vertical wind shear. It really just makes things unfavorable for tropical cyclone development. And typically in an El Nino year, we usually see less tropical activity. So getting into how I created this forecast, what we first want to do is we want to look at, well, what's currently going on now? Well, right now we're really in a neutral phase. A neutral phase is really considered anywhere between minus 0.4 through about 0.4, anywhere between those two ranges. So currently we're in a neutral phase. Anything 0.5 and above is considered an El Nino phase, and anything negative 0.5 and below is considered a La Nina phase. So right now when we look at the sea surface temperatures in this particular region in the Pacific known as Nino 3.4, essentially from 170 degrees west longitude through about 120 degrees west longitude, you can see here that we're really kind of around that neutral phase. We're right around normal. And again, that's over a 30-year period, what is considered normal. But when we look at the model predictions in how our sea surface temperature anomalies are going to behave as we go into the summer and even into the early fall months, you can see that most models are really in agreement that we're going to go above that 0.5 sea surface temperature anomaly threshold. So we're really looking like it's going to be a more of an El Nino year, which I believe NOAA is predicting a 60% chance, at least at this moment, of an El Nino developing. Now you can see that there's a little bit of a question into how strong El Nino develops. You can see the cluster of members really that are kind of hovering around that dark red line are indicating more of a moderately strong El Nino, whereas the lines that are a little bit more centered around the dark blue and then the dark green lines, those statistical models, they're indicating a little bit more of a weaker El Nino, or perhaps maybe even things to remain in a neutral phase going through the remainder of the year. However, if we dive down a little bit deeper, we can kind of look at the models, and these models were ran on April 19th of this year, and we can see which ones are matching the current 0.4 sea surface temperature anomaly as of current. So when you kind of shift through all the noise, these are the models that are behaving the best as of right now, meaning to say that they're capturing the current conditions the best for right now. So if we use those as more of a benchmark and we lean on those models a little bit more, then we can roughly assume that by the months July, August, and September, those sea surface temperature ranges will really be between 1 and 1.3 degrees above normal. So that indicates a moderately strong El Nino, and that coincides with what NOAA is forecasting. So when we look at comparable years to when did this happen last, we really like to pick out years that have gone from a La Nina phase into a neutral phase and then going into a relatively strong El Nino phase. And some notable years is 1951, 57, 65, and 72. You can see that all of these years came out of a La Nina phase, which would be the numbers in blue, and then they went into a El Nino phase, which would be the numbers in red for the months of July, August, and September. So we like to use these as a benchmark. Now there's other notable years like 97, 2002 that we can use as well. But interestingly enough, 1997 has a lot of similarities regarding sea surface temperatures and jet stream patterns, even though it's not the closest proxy that we can use in terms of La Nina and El Nino. So even though La Nina and El Nino, they're really good driving factors into predicting potential hurricane seasons, they're not the be-all and end-all. So we have to look at a couple more things. When you break down all of these years, 1951 has the highest number of tropical storms and hurricanes and major hurricanes. But if you look at 57, 65, 72, and 97, you can see that in terms of tropical storms, really ranges about 7 to 10, which is below the 30-year average. And same thing for hurricanes, roughly about 3 to 4 hurricanes, with about 1 to 2 of those being major hurricanes. So really kind of goes in line with what I'm forecasting for this year. When you look at sea surface temperatures, here's the 4 previous years: 1951 on the top left, 1957 on the bottom left, 1965 on the top right, and 1972 on the bottom right. And this is all for the beginning of May. You notice that years 1965, 1972, and 1957, they all kind of look the same in regards to sea surface temperatures based off the colors and the contours. However, 1951, you can see that these sea surface temperatures are a little bit warmer than normal, which much of the central and kind of going into the southern Atlantic and into the Caribbean already had temperatures well into the mid 80s, which is a prime condition for tropical cyclone development, meaning to say that there's enough moisture and there's enough heat for these tropical systems to really get going. However, when you kind of look at our current year, you notice that as of right now, these sea surface temperatures, they really match a little bit better with the 1965, 1972, and 1957 proxies, even though there's a little bit of differences, and you can see that the sea surface temperatures are a little bit warmer in spots than what they were in 57, 65, and 72. However, right now, these fit better than the 1951 proxy. And actually, if you look at our current year and you compare it to 1997, this is very similar and almost as a really good proxy for how conditions might behave in the next several months. One noticeable feature here is that you do see some more blotches of higher sea surface temperatures right off the coast of Africa, down into Central America, and down through the Caribbean. But what you also notice here is this warm tongue of warm sea surface temperatures off the Gulf Stream current. And that could be an indication for where tropical activity may develop over the next few months. So when you look at the projected overall jet stream pattern for mid-July going into the month of August, you really notice some core features where you have a little bit of a dip in the jet stream over the Pacific Northwest. You have a little bit of a ridge across the northern U.S., a little bit of a crest, if you will, across the northern U.S., places like Montana, the Dakotas, through Idaho, places like that. You also have a large area of high pressure over the south central U.S. You have a little bit of a dip in the jet stream, a little bit of a trough, which indicates areas of low pressure through the Ohio Valley, perhaps maybe even extending down into the mid-Atlantic or maybe even into the southeast U.S. And you also have a very strong bubble of high pressure right off of Bermuda, that subtropical high that's always there that really gives us our most hot and humid days here in southern New England in the summer months. Well, when you look at that and you compare it to 1997 specifically, just because 1997 already has a lot of similarities, so we'll look at that first. You notice that the low pressure areas where you have that dip in the jet stream are very similar, and you also see the high pressure areas are very similar as well. You have the same Bermuda high pressure, you have the same high pressure system over the south central US, and you have the same areas of low pressure in the Pacific Northwest and the same dip in the jet stream near the mid-Atlantic and perhaps maybe even extending down to the southeast US. Now, when you look at things from a 1951, 1957, 65, and 72 proxy, you notice that there are similarities. You still see that dip in the jet stream in the Pacific Northwest and over the Northeast, maybe down into the Mid-Atlantic, even though it's not as pronounced. And you notice that the high pressure zones, they're a little bit more elongated. They go all the way from Bermuda and basically go all the way through Mexico and even into the West Coast. So even though there are similarities here, 1997 still remains a really good proxy, and it really matches what's projected to occur the best. So I'm tending to lean a little bit more on 1997 as of right now. Now, when you look at the sea level pressure anomaly here, you can see that there's a lot of blues or a very light blue colors across much of the US, or maybe even some grays. This is really just no indication of any kind of sea level pressure anomaly, meaning to say there's really no big high pressure zones or big low pressure areas. However, you do notice and again, here's the outline of the jet stream, you do notice that here is a little bubble of darker blues right off of the Florida, Georgia coastline, even off the Carolina coastline, and again extends into Bermuda. And so this is just an indication of where there could be possible tropical cyclone development in this area. But anything that develops in this area may just get carried off by the westerlies in our jet stream, where you can see the blue arrow, and it might not necessarily impact southern New England, which I'll show you in a few slides. However, when you look at what happened in 1997, you'll notice a key feature, this dark blue dot. This is where we have rising motion in the atmosphere. This is an indication of where low pressure systems, or perhaps maybe even tropical development, occurred in August of 1997, which is typically when we start to see a ramp up of tropical activity in the Atlantic basin. When you look at tropical cyclone tracks from 1951, 65, 57, and 72, you notice some similarities, but also some differences. In 1951, you notice that the majority of tropical systems originated off of the African coastline, which is how they typically form. But you notice that they really followed all that warm equatorial water. Remember that 1951, the sea surface temperatures were much warmer in May, so you can imagine by the time we hit August going into September and even into July, you can imagine how much warmer they really were. However, in 1965, 57, and 72, we really didn't have much activity coming off of the African continent. We had a little bit, but not an outrageous amount. And what's interesting is that if you look at 1965, 57, and 72, you kind of see a cluster of tropical systems that really originated pretty much in the Caribbean, maybe a few in the Gulf of Mexico, but really there's a cluster, especially in 65 and 72, where tropical systems originated off of the Florida, Georgia coastline, and maybe even off the Carolina coastline. And you can see here that while southern New England necessarily wasn't impacted because those storms kind of got caught up in the westerlies and traveled further out to sea, you do see that 1972 we did get close in regards to tropical activity impacting us here in southern New England. When you look at 1997, remember we're leaning on this a little bit more heavily, you can see it's very similar to 1972. Not a lot of tropical activity, really had just one major hurricane event, but that was pretty much a storm that went out to sea. But you can see here a cluster off of the East Coast where tropical activity developed. But the light blue colors indicate that that storm wasn't necessarily that strong. So here you can see that there was a limit on how much tropical activity we got. And for the most part, that season really didn't produce many strong hurricanes. There was really only one, which is the longer line with the darker oranges on it. So in terms of New England hurricane setup, in order to get a hurricane or really a tropical system, the classic track, if you will, we really need two things to happen. Number one, there really needs to be a strong Bermuda high. And it's really best if it's set up just east of Bermuda. And the second ingredient you need is you need that trough. You need that large dip in the jet stream that will dip down really into northern Florida, or really just near the Sunbelt states. What that does is the combination of the two, any kind of tropical storm or a hurricane that takes this track, either in the blue line or the red line, it's really forced to only track within the midpoint between the trough and the Bermuda high. So the combination of the two really accelerates these tropical systems into southern New England. But when you look at the frequency of storms over the last 114 years or so, really since the early 1900s, 25 tropical systems have impacted Massachusetts. Most of those, 68% of them, being tropical storms. The other 24% really being the lower end hurricanes, Category 1 and Category 2. Not to say that Category 1 or Category 2 can't be impactful, they certainly can, but only 8%, really just 2 storms out of all 25 have been Category 3, which is the New England hurricane, which is also known as the Hurricane of 38, and Hurricane Carol back in 1954. The last time that we experienced a hurricane was Hurricane Bob back in 1991, which was a Category 2, and before that it was Gloria back in September of 1985. So the main takeaways out of all of this is that there's higher confidence that the 23 Atlantic hurricane season produces less tropical systems, with our most active period really being through July into the month of August. And then it looks like things start to taper off as we go into September and especially October. Now, it doesn't mean that we're completely out of the woods, and it doesn't mean that we can't necessarily see a higher than normal tropical season, as last year was expected to be an increase in tropical activity, but ended up being a low-end tropical season in terms of how many storms it actually produced, even though as we went into the fall months, things started to ramp up a bit. But for most of the summer, it was pretty calm. So it's still important to keep our guard up and still watch where these tropical systems can occur. We might have a few close passes, but the odds are really stacked against us in terms of getting a big one. But again, it only takes the right setup to produce a major hurricane. So not to say that it could happen, but again, the odds are stacked against us. If you have any questions, please feel free to reach out.